We came on board the same day, in July of 1970, and started working in the section on analytical methods headed by Dr. Robert Fulton. And we were roommates, and it became very obvious very quickly that we have a common interest in mathematical methods as they apply to engineering problems. So on that basis, we established a collaboration that quickly resulted in a couple of papers on automated methods for structural sizing. And from there, we went to generalize that to multidisciplinary problems. In fact, ours were some of the early papers in which computers were used to not only disjointly in each discipline, but together to size and configure an aircraft for best performance. This was the time when NASA was interested in supporting supersonic transport, and we combined the programs in aerodynamics, structures, and aircraft performance analysis into one package that resulted in configuration data for an aircraft that we checked against the project proposed by then Boeing and McDonnell Douglas, and we had a remarkable agreement. Olaf was always very good in his approach to computing, which was rooted in his schooling in physics and mathematical sciences. And I was bringing in some experience in aeronautical engineering, so that was a good combination. He, later on in his career, he was called upon whenever there was a new project that required sophisticated and a novel way of using computers, and there were several of them. There was one project which was called Integrated Programs for Aircraft Design, which was a large NASA contract with Boeing for integration of computer-aided methods in the entire design process for aircraft. And then there was a project of developing a specialized mini computer which could perform large structural analysis problems very quickly at unprecedented speed, and Olaf contributed to that too. And most remarkably, that was in late 70s when Project Viking was underway, and they called Olaf to help with computerized analysis of various aspects of that project. Later on, Olaf was always instrumental in bringing in new methods, always to keep up with the development of computer technology. For example, when the supercomputers came on the scene, Olaf developed mathematical solution methods for structural analysis, which were specifically tailored for the use on supercomputers, and he got a coveted Gigaflop award for that from Cray. And most recently, when field programmable gate array computers, or otherwise known as reconfigurable computers, became available, Olaf was the first at the NASA center to, of all the centers as far as I can tell, of bringing that technology on board, and he was instrumental in developing ways and means to actually use this machine for the NASA problems.
Yes.
Olaf is an exceptionally pleasant person to work with, both because of his friendly demeanor and the solid knowledge that he is, and most importantly, ever-present enthusiasm that he was bringing into collaborative work.
that Olaf was my first mentor. Fresh out of school some 23 years ago, as a matter of fact. He was probably the first voice I heard over the phone. And one thing that was a little funny was, I'm very nervous and talking with him, and the first thing I remember hearing him say was, "This is Olaf Thornsberry." And so I called back at different times asking for Dr. Thornsberry, and they told me, "Well, nobody's here with that name." And of course, his name is Storaasli. So I think that was probably my first introduction into his name and trying to spell his name. But yeah, he was my first mentor, and it's kind of interesting because I'm coming from actually a mathematics background and coming into an engineering field. I had a strong computer science background, and one of the first things we worked on was an Atari system, which was, way back when. It was great for gaming, but I actually used it to do some structural dynamics work, and Olaf thought that was very, very novel. And of course, me being fresh out of school, it was the greatest thing. And so he kind of taught me to be innovative in that sense, and we did some analyses on a parallel machine at that time that was just becoming to be a prototype, and that was very interesting because he's always been very excitable and excited about what he does, and he instilled that excitement in me as well. And so that was at least my first recollection of working with Olaf, and certainly he's maintained his excitement throughout the years, and he's had students. As a matter of fact, he prides himself on the accomplishments of his students, and he sends me from time to time little email notices saying that this student has received this scholarship and this student has received some accommodation at school or whatever. And I commented to him that I probably was pretty close to one of his first students, as he did mentor me, as I said, some time ago. So that's been my involvement with him, and it's been certainly very pleasurable to work with him, and he's been a great mentor, and now I think that I'm returning the favor as his boss now. So it's certainly happy and glad and sad to see him go. As a mentor, I think Olaf always instilled, has a go-get-em type attitude. So he would try to figure out things, what were the limiting factors, and he would find a way to get around them or work within the system to get some things accomplished. And he instilled that in me, I think. I try to go by the books in a lot of things that I do, but I always remember, that the branch head's job should be to make his people's job easier. And my boss at that time, early on, and Olaf's boss at that time, Bob Fulton, had that as one of his mantra as well. So Olaf, I think, instilled that in me, and also the excitement for doing the job. And some of the tales that he could tell are inspiring and are still inspiring now. Some of the significant contributions that Olaf has made, I think, fall in the category of high-performance computing. As I mentioned earlier, he's worked in what was new to me, at least, parallel processing 25 years ago. And he began to look at some of these machines that were just coming out. We had one that was actually built here at Langley that Olaf was instrumental in providing applications for. And the significance was that it wasn't a computer science tool, but it was an engineering tool. So Olaf looked at developing applications, structural analysis applications that could take advantage of the parallel processing machines. And I think that was a novel aspect of what Olaf has done, and he's carried that throughout his development work with regard to high-performance computing. I think another notable accomplishment of his is to receive the Gigaflop Award from Cray, which was due to his activities in the shuttle accident of '84 or so, in which he realized the issues associated with solving a system of equations for the solid rocket booster on the machines that were state-of-the-art at that time, and he moved that application out to the Cray machine and was able to do an analysis in much more rapid fashion than what was done here at Langley. And so I think that was a notable accomplishment as well of his. And again, he's maintained that type of innovation as he began to explore a new type of computer in later years, one that's not based upon CPUs, but based upon field programmable gate arrays. And I think his grasp and desire, thirst for knowledge, I think has allowed him to expand the state of technology with regard to those types of systems as well. I think Olaf has affected the morale of the staff primarily by being so upbeat and up-key. He's always been a free thinker and instills that type of thought process within the branch as a whole. Some of the most stimulating conversations that I think I've had in my career have been over the lunch table. And certainly we have technical conversations as well as just personal conversations. News items are key to some of the conversations. And I think he's instilled just that aspect of free thinking, and I think that's important, especially in this time of NASA's mission.
Last year, about, May time frame, I guess, when they decided to move forward with some of the exploration systems work, we were all asked to propose on different projects. And Olaf and I proposed projects that were related to each other, and so we joined projects together. And we teamed together to try to build a better computing system, basically, for space applications. And so we proposed that to headquarters, and then we won. And so since then, we've been putting together our project plan and starting on the work and beginning to architect the system. He helped me put together a pretty diverse team. He brought contacts from a company in Utah that does reconfigurable computing, and he also brought to the table a contact from National Security Agency as well as some people from the Air Force. So he's been pretty good at building a team. So, he's really always he is trying to push outside, and he's very enthusiastic about what he does, and he's very complimentary to the other team members, and he's always trying to sort of bring it out to the community. I think that's one of the things he does best, is his outreach activities in terms of talking at conferences, talking with other people, getting students involved, and he's excited about the work he does, and he does sort of bring that energy into the group, and that helps. So it's a good thing.